Hi everyone, this is Dr. G. Ravindranath Reddy, working as Assistant Professor in the MLR Institute of Technology, Hyderabad. So in this video, we are going to discuss how to find out the Fourier series for the function f of x in the interval minus L comma L. In the previous video, we have discussed how to find out the Fourier series of f of x in the interval 0 comma 2L. Now in this video we are going to discuss in the interval minus L comma L. So whenever we are having the interval in the form of minus L comma L, then the important thing is we have to know what is a even function, what is an odd function, and what is an neither even nor odd. Now first we will see what is the definitions of even and odd functions, and then we can go for the Fourier series, how to find out the Fourier series of f of x in the interval minus L comma L. Okay, now we will see what is the definitions here. Now we will see how to define this even function, odd function, and neither even nor odd function here. So now I have taken a function f of x. Now in this function I want to replace x with minus x here. So if you replace x with minus x here, you will get f of minus x. So by simplifying this, if you get this value is equal to f of x, then this function we can consider as an even function. Even though if you replace x with minus x, if you simplify this value, if you get that value is equal to minus f of x, then this function we can consider as an odd function. And the third case is, if you replace x with minus x in the same function, if that value is not equal to f of x and that value is not equal to minus f of x, then that function we can consider as neither even nor odd. So neither even nor odd is nothing but which is not an even function and not an odd function. That function we can consider as neither even nor odd. Now we are going to find out the Fourier series for f of x which is neither even nor odd in the interval minus L comma L. So now the formula to find out the Fourier series for the function f of x is given by a naught by 2 plus summation n is equal to 1 to infinity a n cos n pi x by L plus summation n is equal to 1 to infinity b n sin n pi x by L. This is we will use this standard formula to find out the Fourier series. Now here we are having three coefficients, that is a naught, a n and b n. Now one by one we will take the formula to find out the a naught value in the interval minus L comma L. So a naught is equal to 1 by L integral minus L to L f of x dx. So this, by using this definite integral, we are going to find out the value of a naught, and similarly in order to find out the value of an is equal to 1 by L integral minus L to L f of x cos n pi x by L dx. By using this standard formula, we will find out the another coefficient, that is an value here. Now the last coefficient, that bn, is given by 1 by L integral minus L to L f of x into sin n pi x by L into dx. Now by using these standard formulas, we are going to find out the values of a naught, a n and bn, and after finding this a naught, a n and bn, we will substitute that values in this standard formula to you will get our required Fourier series for the given function in the interval minus L comma L. Okay, now let us take one example here. So expand f of x is equal to e power minus x as a Fourier series in the interval minus 1 comma 1. So this is our interval where we have to find out the Fourier series. Now once if you observe this interval, this is in the form of minus L comma L. So whenever we are having the interval in the form of minus L comma L, then we have to concentrate on the function f of x. and we have to check whether that f of x is an even function or odd function or neither even nor odd function here. So, by using the definitions of even and odd function, we can decide whether the given function is even or odd or neither even nor odd. So, this is our function f of x. Now, replace that f of in place of x, replace with minus x here. So, you will get minus. So, f of minus x is equal to e power minus of minus x. So, this is equal to e power x. So, this e power x is not equal to the given function, and similarly this e power x is not equal to minus f of x. So, even though if you replace x with minus x, our resultant function is not equal to f of x, or our resultant function is not equal to minus f of x, then we can consider this as neither even nor odd function here. Now, we have decided that the given function is neither even nor odd in the interval minus 1 comma 1. Now, whenever we are having neither even nor odd function, then we have to find out all three coefficients a0, an and bn. So, this is our standard formula to find out the Fourier series, and these are the standard formulas we are having to find out our coefficients a0, an and bn. Now, what we have to do is, so these are the standard formulas we will use to find out the Fourier series in the interval minus L comma L. But in our given problem, the given interval is minus 1 comma 1. Now, since our interval, the standard interval is minus L comma L, so we have taken these standard formulas in terms of L. Okay. So, now, but in our problem, the given interval is minus 1 comma 1. So, now equate these two intervals and get the value of L. So, by equating this, we can get that value of L is equal to 1. Now, if you want to get a standard formula to find out the Fourier series and its coefficient values, wherever we are having L, we have to replace that L with 1. Then we can get our standard Fourier series formula to find out in the interval minus 1 comma 1. So, here we have taken L is equal to 1. Now, replace that. So, this is the standard formula to find out a0. So, now in this we are replacing that L is equal to 1 because we got L is equal to 1 because we are taking the interval minus 1 comma 1. So, replace L is equal to 1 here, 1 by 1 integral minus L to L, that can be written as minus 1 to 1 f of x dx. Now, substitute the value of f of x here. Our f of x, our given function is e power minus x. So, replace that f of x with e power minus x. And then we have the formula integral of e power minus x, that can be written as minus e power minus x. So, this is our integral value, and now you substitute that upper limit and lower limit 1 and minus 1. So, take minus outside. Now, substitute the upper limit in place of x, upper limit is 1. So, e power minus 1 minus e power minus of minus 1, minus of minus 1 is nothing but 1. So, after substituting that upper limit and lower limit, we got this value. So, now if you simplify this, as we have the standard formula e power x minus e power minus x by 2, that can be written as sin hx. So, now in place of x here we are having 1. So, now in the denominator, if you want to convert this exponential function in terms of hyperbolic, so multiply the numerator and denominator with 2. So, you can take this value is equal to 2 into sin h1. So, in place of the powers of this exponential function is 1. So, we can take hyperbolic function sin 1. So, this is our a0 value. So, a0 is equal to, finally we got 2 into sin h1. Okay, now similarly we will find out the value of an. So, take the standard formula to find out the value of an. So, this is our standard formula, but we know that we got that L is equal to 1, replace that L is equal to 1 here. So, we will get 1 by 1. So, you will get, after replacing L is equal to 1 here, you will get 1 by 1 integral minus 1 to 1 f of x into cos n pi x by 1. So, this can be written as n pi x, cos n pi x. In the next step, replace the value of f of x here. So that is e power minus x into cos n pi x dx. Now we have to evaluate this integral. After evaluating this integral, substitute the upper limit and lower limit, then we can get our required EAN value here. So now once if you observe the function inside the integral, this is of the form integral of e power minus ax into cos bx dx. We have the standard formula that can be written as e power minus ax by a square plus b square into a cos bx plus b sin bx. Now use this formula and then substitute the upper limit and lower limit here. So e power minus ax, that is e power minus x by a square. The coefficient of x for the exponential function is 1. So 1 square, that is 1, plus b. Our b is here n pi. So b square can be written as n square pi square into. So a, that is you take this one as minus a. So here, so minus 1 cos n pi x plus b is n pi. So n pi into sin n pi x. Now substitute the limits here, upper limit and lower limit. So you can take that denominator outside. So our upper limit is 1. So e power minus 1 into minus cos n, substitute x is equal to 1. So cos n pi plus n pi into sin n pi. So this is the value after substituting the upper limit, minus substitute the lower limit, x is equal to minus 1. So e power minus of minus 1, you will get e power 1, that can be written as e minus cos n pi x. So if you replace x with minus 1 here, you will get cos n pi of minus x or minus 1. You will get cos of minus theta, that can be written as cos. So that can be written as cos n pi, keep that minus as it is, minus sin, here sin n pi x. This is our function here. So in place of x, replace with minus 1. So if you replace this, we will get this value is equal to sin of minus n pi. Sin of minus n pi, we can take it as minus sin n pi. This is of the form sin of minus theta, that can be written as minus sin theta. So you will get, in place of plus, you will get minus n pi sin n pi. So this is the value after substituting our lower limit here. Now take this e power, so this is sin n pi is, we can take that sin n pi is equal to 0, 0 into anything equal to 0. So this term becomes 0, and finally you will, that remaining term is minus cos n pi into e power this, you will get this, and cos n pi we can take it as minus 1 whole to the power of n. Now similarly this term becomes 0 because sin n pi is 0, 0 into n pi, that is 0. So we can neglect this second term, and here minus into minus plus e into cos n pi, we can take it as minus 1 whole to the power of n because sin n pi is 0. So now in these both terms, minus 1 whole to the power of n and minus 1 whole to the power of n. So in both terms we are having this term minus 1 whole to the power of n. So I want to take that minus 1 whole to the power of n outside. The remaining one is take the positive term outside, e, and the next negative term, that is minus e power minus 1. So here also if you want, you can multiply this numerator and denominator with 2. So this becomes this, we can take it as sin h1, 2 into this one. Okay. Now finally we got that an is equal to minus 1 whole to the power of n into 2 into sin h1 by 1 plus n square pi square. This is the value of an here. Now similarly take the Bn value. This is our standard formula to find out Bn. Here also replace L is equal to 1. So after replacing L is equal to 1, we will get this is our resultant value, and f of x, replace that f of x with e power minus x. Here also you apply the formula of e power minus ax into sin bx. So from this you will get this value. So e power minus x by 1 plus n square pi square minus sin n pi x minus n pi cos n pi x. So use that standard formula, integral of e power ax or e power minus ax into sin bx dx. Use this standard formula and substitute the value of a and b here. You will get this value. Now substitute the upper limit and lower limit here. So take this denominator outside because we don't have any x terms here, because we are substituting the limits in place of x. So this becomes a constant. So 1 by 1 plus n square pi square I have taken outside, and substitute x is equal to 1 here, upper limit. If you replace x is equal to 1 here, you will get e power minus 1 into minus sin n pi into 1. So we can take it as minus sin n pi minus n pi into cos n pi x. Here replace x with 1, you will get minus n pi cos n pi. This is the value after substituting the upper limit, minus substitute the lower limit. Our lower limit is x is equal to minus 1. So if you substitute x is equal to minus 1 here, you will get e power minus of minus 1. You will get e power 1, that can be written as e into minus sin n pi x. So sin n pi x. So in this replace that sin n pi x, x is equal to minus 1 here. So you will get sin of minus n pi. So that can be written as minus sin n pi minus cos n pi into cos n pi of minus 1. So if you take this cos n pi x here, cos n pi x, so replace x with minus 1 here, you will get cos of minus n pi. So cos of minus n pi, this one can take it as cos n pi. So n pi into cos n pi. So this is the value after substituting the lower limit here. Now replace that sin n pi value on cos n pi, you will get our required value here. So e power minus 1. So sin n pi is 0. So I have kept that value is equal to 0, minus n pi into cos n pi minus e into sin n pi. 0 minus 0 or plus 0, you will get 0, cos n pi into cos n pi. Now simplify this. So if you neglect this 0, you will get minus e power minus 1 n pi, and this cos n pi we can take this value is equal to minus 1 whole to the power of n plus. So this is 0, minus into minus plus e into n pi, and cos n pi we can take it as minus 1 whole to the power of n. So in this also we are having n pi, here n pi minus 1 whole to the power of n, here also minus 1 whole to the power of n. So we can take that n pi minus 1 whole to the power of n outside. So the remaining one is e minus e power minus 1. So multiply the numerator and denominator with 2, and in place of this we can take it as hyperbolic function sin h1. So finally you will get, so you will get this value is equal to 2 n pi minus 1 whole to the power of n. This can be written as hyperbolic function sin h1 by denominator 1 plus n square pi square. So this is our final Bn value here. So now we got a naught value, and we got an value, and we got Bn value also. Now once after finding this a naught, an and Bn, immediately you substitute that values in the equation 1. Equation 1 is nothing but the standard formula to find out the Fourier series. So in place of this is our, after substituting L is equal to 1 in the standard formula, we got this is our resultant Fourier series expansion in the interval minus 1 comma 1. So now in place of a naught replace a naught value, in place of an replace an value, and in place of bn take bn value here. So a naught, so we got that a naught is equal to this value 2 into sin h1, 2 gets cancelled, we can take sin h1 plus summation n is equal to 1 to infinity an we got that an is equal to, this is our an value here. So you replace, we have replaced that an with its value and write on this cos n pi x as it is. Plus similarly in the second summation also replace bn value. Just now we got that bn is equal to 2 sin n pi minus 1 whole to the power of n by 1 plus n squared pi square. So in place of bn we have replaced with this value and this value. So keep this sin n pi x as it is. So finally this is our required Fourier series expansion of the function f of x is equal to e power minus x in the interval minus 1 comma 1. Okay, this is the way how we can find out the Fourier series for neither even nor odd in the interval minus L comma L. So if you want, you can expand this by taking n is equal to, otherwise you can take this common term outside, sin h1 and sin h1. After taking sin h1 common from these three terms, this is our resultant series. If you want, we can expand this summation n is equal to 1 to infinity. We can expand this summation and also we can expand this second summation also by substituting n is equal to 1, n is equal to 2, n is equal to 3 and so on up to infinity. So in this video we have seen how to find out the Fourier series expansion for the function which is neither even nor odd in the interval minus L comma L. In the next video we will discuss how to find out the Fourier series of f of x for an even function in the interval minus L comma L. Thank you all of you.